This is the first video lecture of week number 2. In this lecture, we study different methods of finding the limits and continuity. Let's see first simple formulas for finding limits. Please note that here we are not using the method what we have discussed earlier, that is finding the limits by preparing the table, that is numerically, or using the graphs. Here we are finding the limit directly. So let's see some simple 4 formulas finding the limit. 1. The limit of a constant is constant. That is, limit of a constant function for any value of a is constant. Next, limit of a identity function for any value of a is equal to a itself. Look at it. Limit of a constant is constant for any a. Limit of a identity function for any a is the same a here. Then the limit of a polynomial function, note that no denominator here, it is not a rational function. The limit of a polynomial function means you just substitute x is equal to a and you get it. The answer, that is, limit of px becomes p of a. That means we substitute x is equal to a in the polynomial to get the limit. Here, if the limit of fx as f tending to a is L, then I am finding the limit of a radical function. Look at it. I will take this limit inside, that is limit of a radical function means I take limit of inside, so limit of fx. Since limit of fx is L, so nth root is remaining as it is. The final answer is nth root L. Here some of the theorems, some more theorems in finding the limits, and note that the c is any constant means a real number. So what it says, the limit of constant times any function, the constant comes out, we find the limit of only a function. The limit of addition or subtraction of two functions means I find the limit of the first function, find the limit of the second function. If it is addition, add. If it is subtraction, subtract. Limit of product of two functions, find the limit of the first, then find the limit of the second, multiply it. Limit of a radical function, find the limit of numerator separately, denominator separately. So note that the limit of the denominator should not be 0. If it is 0, don't use this formula. So let's see some examples here. This is a polynomial of degree 2. So this is px, and I am finding the limit of a polynomial as x tending to 2. So a is 2 here. I just substitute x is equal to 2 here and I get the answer 6. So here I have shown you here that limit of a constant into function. You see, the constant comes out, limit of only function. Again, limit of a constant and function. See, phi out and limit of x. So limit of a constant is constant. So therefore limit of 4 is a 4. So the final answer is 6 here. So the limit of a polynomial, how we find? We just substitute x is equal to 2 in the polynomial, we get the answer. Note that this is not a rational function. In this example 3.2, we are finding the limit of a rational function where you have a numerator and denominator. So please remember, whenever you have a rational function, the first thing you are going to what you call work out is that you put x is equal to 3 in the denominator. So when I put x is equal to 3 in the denominator, 3 square, that is 9, 9 minus 2 is 7, that means the denominator is not 0. So no issue. So remember, don't find the limit of a rational function without checking whether the denominator is 0 or not. If it is 0, don't use the method. If it is not 0, no issue. See that limit of the rational function means I find the limit of the numerator, limit of the denominator. The same rule I apply. So, limit of first function, the phi comes out, see limit of this, limit of the constant, yes. So, we find all these values here. So, limit of 4 is 4. So, numerator I simplify, it is 16, denominator I simplify, it is 17. So, therefore, the limit of this is 16 by 7. Then we have one example here. Again, we are finding the limit of the rational function. But this time what happens, as I told you earlier, that whenever we find the limit of a rational function, we just substitute the value of x in the denominator first. So, when I substitute x is equal to 1 in the denominator, that is 1 minus x, then the denominator becomes 0. So, therefore, here what we do is we do the factorization or we do the cancellation. That means this 1 minus x we try to cancel, and the numerator we see whether the same factor is in the numerator, and then once you have a same factor, then we can cancel it. We know that here, let's look at it here. The limit of x square minus 1 upon x means I find the limit of numerator and separately here. And this is a quadratic function, that is x square minus 1 is quadratic function. That means this can be factored into two terms, that is linear function x minus 1 into x plus 1. And then this 1 minus x, I take minus outside, then it becomes x minus 1. See that minus of x minus 1 and 1 minus x are same. I just take minus outside. And why I do this? So that x minus 1 cancels here. See that what I have done, what do you mean by factoring here? So, x square minus 1 I factor into two terms, and then once I factor, I will cancel the term. See this x minus 1 cancels. What you get here, the numerator is x plus 1. Don't forget there is a minus here. So, denominator is minus. Look at it, the denominator is not 0. So, therefore, I will substitute x is equal to 1 in the numerator and denominator. The answer is minus 1. Another is the evaluating the limit of a nth root of a polynomial. That is the same thing. Just now I have discussed about the root. Say limit of the fifth root of 3x square minus 2x. So, what I will do? I will take this limit inside. So, limit of 3x square 2x. So, the limit of inside is 8, and look at it, the fifth root will not change. So, therefore, the answer is fifth root of 8. Another important type of finding the limit, I mean a method, is known as rationalizing. When we use the rationalizing, whenever you have a radical term either in the numerator or denominator, look at it, this is not a radical term, this is the real number. You see that x is under radical, that means under root. So, whenever you have a radical term, that is radical term in x, either in the numerator or in the denominator, we are using the rationalization. And in this case also, when I put x is equal to 0, look at it, the denominator is 0. So, what I will do, the denominator is 0, then you have a radical term in the numerator, therefore, I will do the rationalization. So, what I will do, I will take only the function, that is root x plus 2 minus root 2 divided by x. So, what I will do, the numerator and the denominator I will multiply by taking the same radical terms, except the minus becomes plus. You see, root x plus 2 plus root 2, root x plus 2 plus 2. What is the difference between this and this? This is minus, this is plus. The first two terms are same. So, I will multiply and divide this function, I will multiply and divide by the same thing. So, therefore, the function is not changing here. So, what I will do, this is a minus b into a plus b, this is a square minus b square. So, A square means the square root cancels, so you get only x plus 2. Then the square of root 2 is 2, and don't forget a minus b into a plus b is a square minus b square. So x plus 2 minus 2 plus minus cancels, you get numerator x, and I am not disturbing anything, I am just writing x into the same term here. So what I will do, this x cancels, then finally I will get 1 divided by under root x plus 2 plus root 2. If I put now x is equal to 0 here, the denominator is not 0. So always remember, at every step of finding the limit, you are always checking denominator is 0 or not. That's always important. So since the denominator is not 0, therefore the limit of the question, so what happens now, this what you call the function becomes this when after rationalization. So finding the limit of this and finding the limit of this is the same. So limit of this is limit of this term here. So what I do, what is the limit of 1? It is 1, because limit of a constant is 1. So limit of the denominator, I put x is equal to 0, you see, root 2, root 2, root 2 plus root 2, 2 times root 2, 1 upon 2 root 2. So what we have discussed here is different methods of evaluating the limit. Direct substitution, please remember, this is direct substitution when you have no denominator. If you have a denominator, denominator should not be 0. And remember, when you do the direct substitution, you should not get 0 by 0. You have to be very careful, or only denominator 0. Next, we do the, we find the limit by cancellation, that is factorization and cancellation. For this example, you see, when I put x is equal to 2, denominator is 0. But I can do the factorization of this, x square minus 4, I can write it as x plus 2, x minus 2, then x minus 2, x minus 2 cancels, I will get the answer. And the third method is rationalization. When you do the rationalization, when you have a radical term. So this term, I can find the limit of this by rationalization. So how you do the rationalization? The same term I take, instead of minus, I will take plus. So therefore, root x minus 1 divided by x into root x plus 1 divided by root x plus 1 plus 1. So the same term, I only replace this in outside here between the two terms, this minus I will multiply with plus. So that's the, then we have some what you call important simple formulas for finding the limit of what you call trigonometric function, sin x, cos x, and then some inverse function, limit of sine inverse, limit of cos inverse, and limit of tan inverse. So please remember, what I do here, I just substitute x is equal to a, sin x becomes sin a, cos x becomes cos a, sin inverse x becomes sin inverse a. That means I put x is equal to a, I put again x is equal to a, cos inverse a, I put x is equal to a, tan inverse a. And limit of exponential function, you see, I put x is equal to a, e raised to x becomes e raised to a. And limit of the natural logarithmic function, ln x, I just put x is equal to a, so ln a. So remember here, this a should not be negative, so it is always positive. So this 8th is not required here. So in this example 3.6, what we have discussed, here we are discussing what you call, I am just same inverse function I am taking. So I am finding the limit of sine inverse x plus 1 by 2. I put x is equal to 0 directly. So I get this. So sine inverse 1 by 2, you can use the calculator, you can find this is equal to this. So what is the meaning of this? Sine inverse 1 by 2 is pi by 6, means sine pi by 6 must be equal to 1 by 2. So this is exercises, that is book in the textbook pages 85 and